Yes, am I audible?
Yes, sir, you're audible, but some sort of noise is coming from your end.
Is it okay?
Yeah, better.
Okay. So your problem got resolved. Hello.
Sir, I had earlier that question I have not yet. Like book, so
Wait,
earlier whatever book I had, the new one I have not seen.
1 second, please. Hello.
Hello.
Yes, yes. Actually, I'm not getting sound in this headphone. It is coming from outside. That's why. But it's still coming out. It's better.
Like my voice, like earlier class, a bit of echo is coming. Otherwise, it's okay.
Okay. Yes, there is no need of this headphone. So you are editing PDFs now, na? After assignments. You said that your second thing got resolved.
Assignments PDF, sir, that is a different solution section. I'm getting there the PDFs, but with the book and the presentation thing, that is not compiled yet. Like the book we are getting now in the website is only having the transcript, the whatever sir is saying, that one translated.
Mm. Actually, this whole week I was outside. I was attending a part of symposium in Guwahati. Whole week I was not here, so I could not see the messages also. Tomorrow I will tell them, like NPTEL,
Yes,
which I will try to, uh, I will try to solve your questions. Like week 1, figure got that figure problem. That is already like they have
sir, that
published.
figure is there in the solution.
Okay, okay. Now you are getting the solution files. Actually, from your end, what is going on that I have not seen. Like I need to take one ID and password for from some student. Then I will see that what is going on. I have no idea. I was outside this whole week.
Okay, sir. Okay, sir. No problem.
Today we will discuss lectures. Today we will discuss lecture 7 things, week 7 things from lecture 31 to 35. And how many assignments you have solved? Receiving from there, NPTEL. This year solutions, this year assignments. Till where have you solved?
Having T1 11th, the 7th one. So
7.
after today's class, I have to submit 11th.
Okay, okay. Mhm. So we will start the class. And last in last class I told you we will discuss the design of features and hopper and that sheet metering mechanism. So this is the same like as we are discussing since the start, since beginning of the class, that how to design a shaft. We need to first know that uh, from where the weights are, what are the weights are coming. Like we need to know that what is bending moment coming and what is the torsion moment coming. These two things we need to know. If only one is coming, then we have a formula, and only torsion moment is coming, then we have a formula. If only bending is coming, then what is the formula? Sigma is equal to my by I. And if only torsion is coming, then what is the formula? Tau equal to TR by J. Here it is moment of inertia, mass moment of inertia, here it is area moment of inertia. So this we have discussed. If both bending and torsion is coming, then we have a formula that allowable stress tau R is equal to sigma plus 4 tau square. This is the allowable stress of any material, steel or whatever thing you are taking. This is bending moment, this is torsion moment. So for this shaft, roll shaft, this is the weight, its own weight is coming. So for it has its own weight. Suppose W WS is the weight of shaft and WH is the weight of hopper. So total combined weight of this shaft need to carry is WH plus WS, and this will be divided in two sections, means WH plus WS by 2. And this WH plus WS by 2 is acting at a distance of LP by 4, where LP is the distance of this hopper and P is the clearance uh, between the wheel and the hopper. This will not be used. So, and the seed will be uniformly distributed from here to here. So this RA is acting at a distance of LB by 2, and this RB will be acting at a distance of LB by 2. Good. So what will be all the forces acting on this shaft? This RA into LB by 2 and this WS plus WS by 2 into LB by 4. This will try to bend this shaft in anti-clockwise direction, and this RA will try to bend this shaft in clockwise direction. So RA you can take in positive side, and WH plus WS by 2 you can take in negative side. So what will be the bending moment? RA into LB by 2 minus WH plus WS by 2 is acting at a distance of LB by 4. What will be the value of this RA? RA and RB is equal to RA plus RB will be equal to whole product, means WH plus WS. This will be balancing each other. So RA will be equal to RB, which will be equal to WH plus WS by 2. So we can put that value here, means WH plus WS by 2 LP by 2 minus again WH plus WS by 2 into LP by this is actually the distance of LP by 4. So LP by 4. So this will be the bending moment, and torsion moment. Torsion moment we will torsion moment will be from the ground wheel. Because this is the ground wheel, what is the loading resistance this wheel is facing? This will be facing a loading resistance of R. What is the loading resistance? It will be 8% of the 8% of total weight of seed trip, including weight of seed. Whole weight, that whole weight into 8%, and that will be transferred to that shaft, and that will produce torsion in that shaft. So we will take the gear ratio, like if it is rotating at an RPM of ng, and this shaft is rotating at feed shaft is rotating at an RPM of nf, then that transmission ratio will be taken, and torsion moment will be that rolling resistance into the radius of this ground wheel R into mg by nf. So this will be the torsion and this will be the bending. And we have both torsion and bending, so we will use this formula, which is tau max is equal to half into root under sigma square plus 4 tau square. From this, we will solve to get, if we are taking a square section, then for that we will use the formula uh, for bending and torsion both, means y by I, y and I of a square section, and everything will be converted into only one unknown, that is b, and we can, and tau max for knowing ms and tau s we have calculated. So from there we can calculate the dimension of shaft. For furrow, the design of furrow opener, we have discussed in cultivator that that same thing will be applied here. Suppose in cultivator, because that the seed drill you can see, seed drill figure or attached here. If you will see a seed drill, you will find that the furrow opener is same as the working element of cultivator. So design of furrow opener will be same here, same here also. So for design of the same, what we will do, what we are doing here, at bending moment we are calculating, and what is torsion we are calculating. So if working element is shovel type or sweep type, full sweep type, then only bending will happen. And if it is half sweep type, then torsion will also be coming into the picture. So first, and which force will cause bending and which force will cause torsion. That is the only thing we need to know in every process we are doing. So what force will cause bending on this in this sign? This is the sign, and which force will cause bending and which force will cause torsion.
Vertical and horizontal. Within that, we have to think.
Hmm.
So the vertical one will cause bending and horizontal will cause torsion.
Hmm. Vertical is called will cause bending in the shaft, not in the sand. This is just a shank. This is the shaft, and this is suppose 5 cm there. So in this shank, which force will cause bending? This, like horizontal force will cause. And on this shaft, that all the vertical forces will cause bending. That thing you need to understand very good. I see the shaft. On this shaft, bending is due to vertical force, and on this, in this side, bending is due to this force. You're getting?
Yes, sir.
That is
Yes.
the key point you need to understand. In this shaft frame, in this frame, bending will be due to KV, and torsion will be due to,
KH.
yes, KH will cause torsion in this frame, because this KH will try to turn or twist this frame, and KV will try to pull it down. It is this downward force. So KV will cause bending and KH will cause torsion in this frame. And for this shank only shank we are considering. Then this shank is subjected to bending due to this horizontal force, that is KH. And what force will cause torsion?
KV.
No. First thing you need to check here is that whether this earthing element is symmetrical or not. If it is symmetrical, then there is no question of torsion moment. If it is not symmetrical, suppose half shape type like working element is there. This is half shape type working element. Then this KH only will cause torsion. KH is causing torsion in this also, and KH will also cause torsion. KH will cause bending in this side, and KH will only cause torsion when it is not symmetrical. Suppose symmetrical at this point, suppose at this point it will try to twist this side. Are you getting? This KH is now try to twist. This KH will now try to twist this side.
So both the forces will act at the same time. If it's bending, then torsion will be there, or
If it is symmetrical, then KH will cause only bending to this sink. And if this working element is not symmetrical, then that KH will only cause torsion in this position. This thing we have discussed in cultivated class. And at what distance that also I have so like at some distance, suppose working element is of width W, then W by 2 at W by 2, this force, this KH will act to cause torsion. Suppose W is the working width of this not unsymmetrical working element, then this KH into W by 2 will be the torsion moment for this shell. And this KH will cause bending and at a distance of this height, this KH into H. This KH will only cause bending and torsion, but at different terms for bending and torsion. If you visualize, then it will become more clear. So what will be the total height? That also we have discussed earlier. A max plus H1 plus delta H, whatever it will come. Delta H is the here the frame is attached, so we can ignore this delta H. So H1 plus A max, H1 plus A at this height, KH will act and it will cause bending. And so if we have a known value of this H1 and A, and KH we need to calculate from that load angle. And from there we can calculate this is sigma and y by I. I by y is called Z, section modulus by I by y. This I by y. So this is the allowable stress, and we take some factor of safety. So design stress will be divided with the allowable stress divided by factor of safety. 150 for 150 is for steel. So 150 by 3 is the design stress. 50 megapascal will be the design stress. That will be equal to M1 by I. And for rectangular section, BH square by 6 is the section modulus, and BH by B ratio we take as 3 is to 1. And from there, we get only one unknown, that is H will be in terms of B, that is 3B. And from there, we can calculate B directly. So from that bending stress only we have calculated this design time concept, that is B. If there would have been torsion moment also, that means how would also have been there in picture, that then T I by J would have been there, and design stress would have been tau max is equal to 1 by 2 root under sigma square plus 4 tau square. We have only sigma here. That's not torsion unit. So sigma is equal to M y by I. From here we will calculate the design dimension of this shell. Force acting in the frame. Now, just now we have discussed that for this frame, what will be the bend? For this frame, there will must be bending and torsion both. There is no of symmetrical or non-symmetrical element. This will be subjected to bending due to this kV and its own weight, that is some weight of this whole implement. That will cause bending, and torsion will be caused due to this horizontal force, that is unavoidable, that is KH will always be acting at this distance, at the distance of this shaft. So this KH will be causing bending, and this kV and the mass of the shape will be causing torsion, will be causing bending. In this case, will be causing torsion. So you can see here that forces forces are movements acting on the frame. So R1 and R2, if it is a normal reaction, which will be equal to 1, 2, 3, 4, 5 kV. This weight and this whole element has a weight of W1. So weight W1 will be the weight of 9 times. So for 5 times, the weight will be 5 W1 and 2. From here, we can calculate R1 is acting at a distance of T0 by 4 plus 2 T0 plus 2 T0, which is here. And W is the ground weight. W is the weight of ground weight. That is also divided here. And it is acting at a distance of this whole distance. That is T0 by 2. This distance is T0 by 2. This is 2T0, this is 2T0, and this is T0 by 2. So 2T plus 2T 4T plus 4.4. So this WW is acting at a distance of 4.5 T0 and KB is acting at a distance 1 kV is acting at a distance of 4 T0, 1 kV is acting at a distance of 2 T0. So 4 T0 and 2 T0, and this of the weight of the frame, total weight of this central element, that will be divided into parts, that is WG by 2, and it is acting at a distance of this whole weight minus by 2, that is 2.5 T naught. 4.5 by 2, that is 2.25. It should be 2.25 T naught. So the values now we are knowing, T naught we are knowing, WG we will be knowing, R1 we will calculate from this process, and we can calculate bending moment. And what will be the torsion moment? Torsion moment will be due to KH at the height of sun. So that will be KH into this is the height of sun. That will cause torsion, and this will cause bending. And from there, we will use that formula. This one tau x is equal to half root under sigma square plus 4 tau square, and that will give you the design dimension, that is B. So that was the procedure of calculating for designing the feeder shaft and frame. And if we have known values, then you can see that you can see the procedure, same procedure that we followed for this design, for this feed rule. Bending moment has come 92 Newton meter. Torsion moment has come this 13.85, and we have got this B, that is design of shaft as a dimension, square shaft as a dimension of 2.08. 2.08 with a square shaft dimension. Now next thing is metering unit. For fluted roller, you can see that this is the design of fluted roller. Now you can see there are two. This is the most complicated thing in the serial design. See, it has two little things. It has two diameters. That is first thing you can observe. This is the larger diameter, larger radius, that is d by 2. This is the smaller radius, that is small d by 2. But you can denote it as capital R or small r. That is the one thing you can observe. Then second thing you can see, that first thing we saw is diameter. Second thing you can see is it has two area. One area is this, and one area is this one, where this grain is sliding. So how many what is the weight of seed that is coming out in one evaluation? We need to consider the area of this unit and area of the seeds which is sliding also. So that will be coming into picture. Here you can also see this area is there and one this area is there. So we will derive the formula for knowing what is the volume of seed coming from this feed row, from this project row. So that for that you can see that if we were taking, just now we have seen that suppose this is the floated rollers. This is the floated roller. Can you visualize it? Like it will be having two layers. One is internal area and one is the external area. It will be comprised of this A1 and A2. Two area will be there. And like this, there will be seven, like number of, how many number of fruits will be there? That number of area we need to consider, and that will be divided into length, area, into number of fruits, into length. That will give a rough picture of what is the volume of seed coming. Yes, are you getting?
Sir, you multiplied area into
Area into number of fruits. That will give total area of that fruited roller from which is of our interest. Only this area, from this, only in this area, only in this area, seeds are there. And suppose there are seven fruits, so there will be seven types of this area. And this area is comprised of one external, uh, one this like of larger radius area, and one is having smaller area. See this picture. From here you can see that there are two areas. One is this one, and one is this one. Getting?
yeah, yes, sir. To that earlier section you have shown,
Um,
overlay that one.
so this A1, just now I have written it here. This is A1. That is in the picture I have shown it as A1, and this is A2. It is also shown here. See, this is A1, this is A2. This smaller one, this diameter, this for this diameter is small, and for this diameter of this circle is large. This it has a larger it has a larger circumference, and it has a larger radius. And for this circle, it will be having a smaller radius. It will be having a smaller radius for this one. So that thing has been shown here. This is smaller radius, this larger radius. Getting? Now the concept you need to follow here is that what will be the volume of seeds coming out from this flooded road? That suppose some VS is coming, and from the design, from the calculations of what will be the seed rate, suppose 100 kg per hectare is the seed rate. From that, what is the desired what is the desired volume of seed we need to, that is what is the volume of seed that is coming from that is coming with when this ground wheel is rotating. When this ground wheel is rotating, that feed roll is rotating, that feed shaft is rotating, and that is giving some volume. That from that thing we have discussed many numericals in last class. Suppose in one revolution of ground wheel, this is rotating suppose two times. So in one revolution, this is rotating two times, and that will give us that what is the volume or what is the amount in kg of seed that is dropping from this feed row. That is one procedure. One procedure just now we have seen inside the filter row. That what is the volume of seed coming from this fluid. That is one. That is from there one volume is coming, and from this calculation, what is the speed and what is the gear basis from there one volume is coming. So see, suppose from this example, we will get it. Suppose what is the area covered when the seedling is seedling is operating at a speed of 4 km per hour, and it has a working width of 9 into 20 centimeter. So what will be the area covered per minute? 4000 by 60 meter per minute into 9 into 20 by 100 meter. This is the width it is covering, and this is the distance it is covering in 1 minute. So when you will do this multiplication, you will get that 613.33 meter square it is covering in 1 minute.
Excuse me, sir.
Sorry.
Sorry for interruption. Your voice is not very much clear, sir.
Yes, Samsung.
No, your voice is not very much clear actually.
Okay, I will wait 1 second. Is it better? No?
Sir, just speak on, sir.
Wait 1 second.
Now I think it's okay, sir.
Hmm.
While I am speaking, I'm getting that resound also.
Wait, let me rejoin. I will rejoin. Hello.
Yeah, now it is okay, sir.
Is it okay or you are saying just okay?
It is okay, sir. It is okay. Now there is no disturbance.
Okay. So suppose seed drill is covering this area in 1 minute, and mass of seed to be dropped, that is the seed rate is 100 kg per hectare. Suppose 100 kg should be dropped in 10,000 meter square. So for this area, what will be the seed? What will be the seed in kg? That is for 1 meter square, it will be 100 by 10,000 kg, and for this area, it will be this
Into
amount of
613.33.
613.33. So we will get 6.133 kg. This for this area 6.133 kg should be dropped. Assuming the diameter of ground wheel is 60 centimeter, so number of revolution in 1 minute what will be the number of revolution in 1 minute? In 1 minute, how much distance it is covering? 4 kilometer per hour, means 4000 meter by 60. That is the distance it is covering in 1 minute. 4000 by 60. This much distance, and this is the diameter of ground wheel. So from there, circumference will be pi into d. So pi into d will be, suppose, this amount. So this is the distance it is covering in one revolution. Total distance it has covered in 1 minute is 4000 by 60. So 4000 by 60 divided by pi into dg, the meter per hour. So 4000 by 60 divided by pi into dg will be 30.36. So this is the RPM of ground wheel. And for this RPM, mass of seeds to be dropped in one. This is the revolution in 1 minute. So mass of seeds to be dropped per revolution. In one revolution, it is taking 35 revolution. In one revolution, what is the mass of seed being dropped? 6.133 divided by 35.36. That will be the mass of seed in one revolution. And it has 9 rows. It has 9 rows. So that will also be divided. So this amount of seed by, for one revolution, we will divide by number of revolution, and number of times will also be divided. So this will give 0.013 kg. So this amount of seed is being dropped by one fluted roller in one revolution. In one revolution, this amount of seed is being dropped by one time. Means from one time this amount of it is coming. And if the transmission ratio from ground wheel to feed through is 1.1, 1:1, means in one revolution of ground wheel, one times that shaft is rotating, feed shaft. So this amount of seed will only be coming out. And for suppose one ground wheel revolution, two times that shaft is rotating. So what will be there? This seed will be coming. This seed is coming in one revolution of ground wheel, and till that time, in that time, shaft is rotating. That feed shaft is rotating two times. So in one times, what will be the amount of seed coming from that metering unit? On this divided by two. Are you getting?
Yes, sir, I'm getting.
Jigyasa, are you getting?
Yes, sir.
So if in one revolution of feed shaft, ground wheel is rotating two times, then what will happen?
Sir, come again, sir.
If ground wheel, if for one rotation of that feed shaft, wheel is rotating two times, then what will happen? This is the feed shaft. It is rotating two times, and in that two times, this ground wheel is rotating only one times.
Sir, can you just zoom out that value, sir? Still more, sir.
This concept, we need that this concept should be very clear, then only schedule problem will be solved very easily. I'm saying that in one revolution of ground wheel, feed shaft is rotating two times. Then what will be the effect of that transmission ratio on this amount?
Volume will be reciprocal.
Here it is 1:1, means one revolution of ground wheel is rotating one times that feed shaft. And if one revolution of ground wheel is rotating two times of that feed shaft, then what will happen?
volume will be the volume of that seed which is dropped will be mm,
Then what will happen? Volume of seed drop per revolution by feed roll will decrease. Will decrease by 2 times. We need to for only one revolution. For 1 ground wheel revolution, it is rotating 2 times. So and this amount is coming. So this amount is coming in 2 revolution of feed slot. Either you can say this amount is coming in 1 revolution of ground wheel, or
okay,
you
sir.
can say that this amount is coming in 2 revolution of feed slot. This type is this concept you need to understand. This amount is coming in either 1 revolution of ground wheel or 2 revolution of feed slot. That will make you clear. So this amount is coming in 2 revolution of feed shaft, means 1 revolution of feed shaft will give this amount by 2. That is the importance of that transmission ratio.
Okay, sir. Okay.
So this amount is coming, and density of seed is here taken 750 kg per meter square per meter cube. Means in 1 meter cube, the mass of seed is 750 kg. So this kg will be converted into volume, that is 25.73 centimeter cube. So in 1 revolution of feed shaft, roll shaft, in 1 revolution of feed shaft, what is the volume coming? 25.73 centimeter cube. This is the calculation from which side, ground wheel side, hectare, like what is the speed at which the seed drill is operating, and what is the transmission ratio. From that side, we have got that 25.73 centimeter cube should be dropped by feed shaft in 1 revolution. This part is complete. And another part which we are discussing from beginning is that what is the volume need that what is the volume that should be coming out from this dimension, that we will also discuss. So it has not two formula. Volume of seed displaced per revolution by fluted roller is given by this formula. This is a direct formula from when we are knowing the diameter, that larger diameter and the smaller diameters. So if the porosity is suppose alpha, means suppose 20% is the porosity, means that amount is occupied by air. So 1 minus alpha we will do with for this 1 minus alpha into pi d square minus d square. This is larger diameter and the smaller diameter. We have discussed what is larger diameter, this one, and this is the smaller diameter. So pi d square minus d square, that will give this is the area for pi d square, and this is the area for smaller diameter square. So this is the area we are getting from that subtraction. So from here we are getting that, and 1 minus alpha is the porosity and LF is the length of fluid. So that is one way, and another way which we were discussing is that this area into number of fluids will be there, and area and length of fluid will be there. So for calculating this area, this is comprising of two area, A1 and A2. And how to calculate this A1 and A2, that we will just derive. So A2 is A1 is the part of this larger circle having radius d by 2, this one, and this area is part of a smaller circle, that is this one.
Sir, both the formulas are accepted.
Both formula will be acceptable. It depends on what is given. If
Sir,
suppose area
just scroll up, sir. Okay.
If
So here you are telling that actually we are taking the area of circular ring, right?
uh,
Small diameter, smaller diameter, and we are subtracting larger diameter from smaller diameter. That we are getting the area of that circular ring, right?
yes,
Sir,
yes,
but that circular ring, if we are taking the circular ring, we are covering some area which is not dropping the seed, right?
that's why this formula will be more. This formula I think will be more suggested to
Uh-huh.
use.
Yeah, yeah, that's
And
what
for
I'm asking.
and here for calculation of this S is also important. This S is this part is indicating the area of means the volume of seeds which is sliding along this periphery. This
Okay.
this is S1 and this is S. So this part of seed is also coming out and that should also be considered. So that part plus this part that we need to consider that will add up and give volume. So for calculation of this S, we have formula S1 by M plus 1 and M for B it is 2.6. So from there S will be calculated and this diameter we can calculate. This suppose
Yes, sir.
calculate.
Actually, that I got, but I think the second formula is more relevant. Why? Because we are
Mm,
exactly taking the volume of that semicircles, right? That
yes,
flutes.
that is more accurate. Mm,
More accurate because in others, if you see, we are also covering some area which is not dropping the seeds. That
yes, yes,
straight
yes,
part.
yes. Mm.
Okay, 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 sir. Carry
So
on.
this area is A1 and A2 and A1 what will be the area of suppose we are calculating A1. A1 will be this this is called what?
Sector, sir.
This is called this conical shape is called Bhatin circle.
That is one sector, right?
One
Sector.
sector, yes,
We'll
correct.
call it a sector, I think.
Yes, sir.
Yes.
Sector. Correct. So area of this sector will be what? So for 2 pi the area is pi d square by 4. So for alpha, this alpha area will be pi d square by 4 into alpha by
Into
2 pi.
alpha by 360. Okay, okay,
So
okay,
this
okay.
is the area of sector, that larger sector. And that will should be divided by that should be subtracted with this triangle's area. This triangle's area, uh, one formula is there, 1 AB into sine C, where A and B is the side of the triangle and C is the included angle between them. So this is d by
Yes,
2,
sir.
this is d by 2, and this is sine alpha. So half into d square by 4 into sine alpha will be area of triangle. So d square by 8 into sine alpha. D square by 8 sine alpha is the area of triangle and this pi cancel. This is giving d square alpha by 4. This is square d square alpha by 8. So this area minus this area. So this will become d square by 8 into alpha 1 minus sine alpha or sine alpha 1 or alpha just alpha. So this is the area of this A1. And for smaller sector A2, we can derive it in similar way and it will come as r squared by 2 beta minus sine beta. And this will come as d squared by 8 alpha minus sine alpha. So adding both the area, we will get d squared by 8 alpha minus sine alpha and r squared by 8 beta minus sine. And this is, and what is B? B is regarding that thing. This area which we are not considering, delta P, which is not dropping the seed. So that thing we also need to consider. And that area, this area, if we are knowing A1 plus A2, then number of fruits we are knowing and length we are knowing. Area, that is dropping the seed into number of fruits, that will give total area into the length, that will give volume. Are you getting? Meter square into meter of future roller, that will give meter cube, means volume of the seeds dropping. And pi d SLF is regarding the seed that is sliding, and that should also be considered. So it is also, now this is the thing which we are calculating from that side. What will be the gear ratio? What is the ground width? That from that side we are getting one volume, and what one volume we are getting from this side. So we need to equate both the equation to get the desired value which is being asked, which is to be designed. So suppose 2.573 was the volume of seed which we have calculated from that calculation. 2.573, 2.25.73 is the volume of seed being dropped in one revolution of ground wheel, and area into 7 number of fruits into capital D is 8 into 0.278 is the S, then 1 is length of fruit. From here we can calculate area as 2.678 centimeter cube. And B, we have this formula, so we can calculate B also, 3.47. So here, if suppose I think B was asked, so this was done. And design of hopper is also there. Design of hopper is simple only. Like first you need to know that what is the hectare per hour from field capacity. Actual field capacity, first you need to know. For that, you need to know the width. W into S by 10 is the famous actual field capacity formula. You need to divide it with field efficiency. You will get what is hectare per hour. So for that hectare per hour, you need to know that at what time you need to refill. For suppose 1.4 hours, you are refilling the hopper. So this amount, this area, this hour will be multiplied and 0.576. So this much area is being covered. And what is the seed rate? Suppose 100 kg per hectare. So this will be the amount of seed for which the hopper needs to be designed. And this is the amount in kg. You need to know that what is the density of the seed. From that, the volume of seed will come. This will be the volume of seed coming from the actual field capacity. And if you are taking triple cross section, then there are some standard theta and c values which you need to know. But from there, you can calculate what is the dimension of hopper. So in this week's, these were the questions. We will solve these questions now. So furrow covering device we have discussed in last class. So which of the following is not a furrow covering device?
Round wheel, sir.
Yes, ground wheel. Press wheel is furrow covering device. Drag bar is drag chain. This we have discussed that
Right,
these
sir.
all are furrow covering device. And ground wheel will be the answer. So second question is, if the volume of seed collected from one row of a seed refilled with fluted roller metering unit in one revolution is 41.32 centimeter cube. So this is the volume of seed collected in one revolution of seed drill from that fluid. So, and the metering unit with outer diameter is 80 mm, comprising 7 fluids. Area of cross section is given 2.5 centimeters square. So, assuming the coefficient of material reduction is 20%, the thickness of active layer is 4 mm, means that S. The exposed length of fluted roller in centimeter will be. What will be the LF of length of fluted roller? So we have seen that what is the volume coming out should be equal to area into number of fluids, quantity suppose into LF into some amount of porosity, that is 1 minus alpha, will be taken by, due to porosity, this amount is getting reduction, and this should be added with pi d s LF. This is the red sliding force. So LF will be common. So 1 minus alpha into area into NT plus pi ds. This should be equal to 41.32. Alpha is given 20%. Area is given 2.5 centimeter square, and there are 7 flutes. Diameter, outer diameter is given 80 mm, and thickness of active layer is given 4 mm. So calculate this value. Zero point 0.8 into 2.5 into 7 plus 3.14 into centimeter, it is 8 into
Sir, 1.847, sir.
0.
Near, okay, nearby answer is D, sir, 1.8.
Okay, that is coming now. Jigyasa, are you getting that value? Okay, means 1.85 will be the answer. So next question is this one. You need to tell that what is the area of cross section, or what is the area of this shaded region.
Direct questions are just before we have seen. And
Yes.
option B.
Yes. Alpha minus alpha, d square by 8, and here it is d square by 4. So d square by 8 will be the correct answer. So B is the correct answer.
Option B.
Now, whatever we have seen from that only, you can design a drum seater. Drum seater is nothing but there is a drum which is attached, which is mounted on a shaft, and there are a number of holes on its periphery. So if we are knowing the concept of seat drill, we can solve these questions. So here it is asking that a dryland drum seater of a length 60 centimeter it has diameter of 22 centimeter for sewing wheat seed in 3 rows. With a row to row spacing of 20 centimeter. 1 into 20 is supposed to be 10. The effective diameter of case wheel is 35 centimeter. It has a case wheel. There is a picture of seed drill that I will show in next class, which has a case wheel which rotates this shaft. So this case wheel has a diameter. Suppose that case wheel is giving power to this shaft. That is the basic thing. So 35 centimeter ground wheel type thing is there. That is called case wheel. It has an effective diameter of 35 centimeter. The maximum weight of the seed which can be accommodated is 10 kg. The maximum weight of seed which can be accommodated in the drum is 10 kg. Assuming 2 seeds being dropped for each hole. It has number of holes here attached. So each hole is dropping 2 seeds in. So and 50 gram of 50 gram of seed has 1000 seeds. Means 1000 seeds when tested it was having a weight of 50 gram. seed rate is 100 kg per hectare, what will be the spacing between the holes? This spacing between the holes you need to calculate. This is like means if you are getting the concept, then this you can solve. You need to know that what is the number of seeds coming and what is means number of seeds. If you are knowing that what is the number of seeds coming in one periphery and what is the distance of periphery, like circumferential distance, if you are knowing number of seeds, if you are knowing that how many seeds is being dropped, from there you can calculate the spacing between the holes. So first we will calculate that what is the number of seeds being dropped by one hole, by one this alignment of hole in one revolution. This question is a bit lengthy. So do you have idea how to proceed? So first calculate what is the in one revolution what is the area covered by this seed by this drum shifter. So in one revolution what will be the area covered? Diameter of ground wheel is 35 centimeter. So pi dg. Pi into dg will be the distance and what will be the width? Width is 3 into, it has 3 rows and at a spacing of 20 centimeter, means 3 into 20 centimeter. This is the width and this is the distance pi dc. So 3.14 into 35 centimeter is 0.35 meter.
0.65.
Area. Okay, in one
Yeah.
revolution, it is covering an area of what area you said?
0.65.
0.65 meter square. And in one revolution, this 100 kg per hectare. 100 kg per hectare is the seed rate. Means 10,000 meter of square seed is needs 100 kg. In this area, 100 kg of seeds to be dropped. So in this area, what will be the seed drop? 100 kg by 10,000 into 0.65. 0.0065 kg. So here it is clear.
Yes, sir.
So this kg is being dropped in 3 rows. This amount is being dropped in one revolution in 3 rows. So this divided by 3 will be for one row. You're getting
0.002198, sir, in I mean in one row.
in one row
Cages.
it is 0.002198.
2198.
Okay. So this amount is being dropped in one revolution. And this and how many seeds? Now you have to see that this amount is comprising how many seeds. So 100 gram, sorry, 50 gram was comprising of 50 gram was meaning 1000 seeds. That was the test weight. Here it is written 50 gram has 100 seed, 1000 seeds. So 50 gram has 1000 seeds means this amount will be how many seeds?
0.043.
0.043 seeds.
9. Yeah.
0.043 seeds. You have done some mistake. Kg is there. Here it is gram. So do carefully. In 1000 you are leaving. Jigyasa. Kg you need to convert in gram.
44.
So 44 seeds will be coming out in one revolution from one row. Till here it is clear?
Yes, sir.
Yes, sir.
And 44 seeds is coming in one row from these two holes. Like if what is it is written as 16 24 somewhat. Now you don't need to consider that one drum seeder has two holes, two number of rows for holes. If it is not written, you just consider that one drum is giving only one drum has one periphery of number of holes. So it has number of holes on its circumference and 22 seeds are being dropped in one hole. So 44 seeds are there. 44 seeds are there. That has been dropped by one hole is dropping two seeds. So what will be the number of holes?
22.
22, sir.
22 holes. And that is taking a circumference of what is the circumference of that drum? This drum circumference divided by 22 holes we need to do. So drum has a diameter of 22 centimeter. So 2 pi r you can do. 2 pi r divided by 22.
3.14, sir.
Means 2 into
3.1.
22 by 7 into radius is 22 by 2 into 22. So 22, 22, and this is cancelled. This is 3.14.
Option C, sir, 3.14.
Yes, this we have solved. This was a lengthy question. I think if you get this question this week, then it will be very easy for you. So next question is, if the total weight of paddy drum seeder rolling radius 20 centimeter is 25 kg, find the torsion moment on the shaft supporting the seed drum in Newton meter. So what is the torsion moment? Taking rolling radius resistance as 8% of weight. 8% of total weight means 0.08 into total weight is 25 kg. So you have to convert it in Newton, that is 9.81. This is the force acting, and at what distance it is acting? At rolling radius of 20 centimeter. Directly multiply it with rolling radius, that is 0.2 in meter, and this is in Newton. So this is Newton meter of torsion moment acting. This amount is in Newton, and this at this moment R, that force is acting, and that is given.
Option B, sir, 3.92.
So option
3.92. B.
Option B, sir.
3.92 meter meter. So next question is, If the vertical cell planter has 35 cells, around a disc of 28 centimeter, and is operated at a forward speed of 4 km per hour, the seeds are released from vertical rotor rotating at a peripheral speed of 25 meter per minute. Assuming 100% cell fill, the seed rate, seed to seed distance along the row in centimeters. So this is linear velocity, and velocity is equal to r omega. And omega is 2 pi n. So finally we need to know what is RPM. So what will be the RPM of rotor, and radius is given. From there we can calculate seed to seed distance along the row. We first need to calculate what is the RPM. So any idea how to solve this?
So from the V equal to R into 2 pi n, we can calculate RPM.
Vs
Is given here, so from there.
okay. This is given like 28 centimeter with the diameter is pi into 0.28. This will be pi, and pi and d is the formula for velocity. So pi and into d is equal to 25 meter per minute. So from here you can calculate n. What is RPM?
28.4349.
28 point
4349.
434. 28.43 rotation per minute. And what is the, it has 35 cells. So in this amount is in this number of revolution, how many seeds will be coming? In 35 revolution, in 35,
995.22.
in one, this is RPM. So in 1 minute, it is rotating 28.43 times. And in one rotation, it has 35 cells, so 35 seeds will be coming. So in this number of revolution, 35 into, in 1 minute, 28.43 into 35 seeds will be coming in 1 minute. So in 1 minute, how many seeds are coming? 9, 37.
995.2229.
995.5.
So I'm getting.
Okay. This amount of seed, suppose you can consider it say 995 seeds. So this amount of seed is coming in 1 minute. And in 1 minute, how much distance it is covering? 4 kilometer per hour. So in 1 minute, what is the distance it is covering? 4000 by 60 meter it is covering in 1 minute. And in 1 minute, this amount of seed is being dropped. So from there, you can calculate seed to seed spacing. So 4000 by 60 you do what meter it is there, and this you divided by 995 means 400 by 6 into 995 will be the spacing of seeds in meter. Here it is asking in centimeters, so multiplied with 100.
Option D, sir, 6.7 centimeter.
Okay, option D was, which is there, 6.7 centimeter. So next question is the dimension of shaft of a dragon drum seeder is dependent on number of rows of seeding, weight of seed drum, weight of case field provided for preparing the seed drum. So we have seen that weight of seed
Direct question, sir. All of this.
versus all of this.
Option D.
Mhm. So next question is quality of feed index. This we have discussed in previous class, week 6.
C
Yes, sir.
answer.
Option C, sir.
Option C. So while deciding the size of hopper, the factor to be considered, seed rate, working weight, number of fillings.
D, sir. All of this.
All of this. So next question is which of the following statement is not correct for seed tubes used in seed drill planter? I think this we have not discussed, but if you will see the lecture, you will find that diameter of seed tube to is diameter of seed tube to be such
Sir,
that
A.
travel of between. This is considered. This we have seen that amount is subtracted.
Sir, the D option. Okay.
Okay, good. So this first
Sir,
factor
I
is
think
considered.
option is C, sir.
Sharp velocity should be avoided, and this is also considered. That should be avoided. The maximum deviation to
Option is C, I think, sir.
Sir,
this
D
amount
will be the.
this has some different amount that this degree maximum deviation. So C will not be considered. There are some values, but this amount has been changed. That's why C is incorrect. Is not correct. Most probably vertical is also correct. So this question we have solved regarding week 7. So if you solve week 7 today, when is the last day? You are
Tomorrow.
Tomorrow, sir.
you people are on week 7 now.
Yes, sir.
Solve this week question. I think it will be easy for you now. So if you face that problem, did you solve week 6? Jigyasa? Questions were
Yes.
you solved all the questions. No?
Yes, sir.
Sam Sundar. Hello.
Yes, sir.
So up to week
Hello?
6, you have done. No?
Yes, sir. Week 6 I have done, but actually I was getting the answer regarding, just I'll tell you, sir.
You were getting the answers.
Yes, sir. Actually, week 6, there is a question regarding that seed drill, na, sir. Like they have given that length of the lug.
That question is solved in last class.
Yes, sir. No, actually, I'm getting the answer, sir. But while solving it, I have taken overall diameter. I didn't subtract the lug value. Because of that, I got wrong answer.
Oh.
So rest of the questions I have solved.
So you can submit it like next time. No, there is no limitation. I think. Uh,
Yes, sir. Week 6, there is no option, sir. That's week 6 has passed. So
oh,
week 7 only now we are having option. Tomorrow we can submit.
okay, then complete week 7. Then we will meet in next class.
Hmm. Okay, sir.
Okay.
Thank you, sir.
Okay. Thank you. Jigyasa, you have any doubts?
No, sir, not yet.
Okay, then we will end the class. We will meet on next Monday, same link, 6 to 8.
Sir, earlier that question was there in last class. I sent.
Actually, sir may take a live session. My master will take a live session. There you ask that question like all the doubts now that we will get some PDF or you interact with sir directly. Whatever doubts you are getting in previous questions. Like one doubt session, sir will run.
Sir, I think week 5 or week 3, I don't remember. I think week 3, sir. I think you didn't modify that question. The data was, the options was not matching with the answer, right?
I told them like,
So,
but if once it is published, no, they cannot modify. They will just give marks to all of you if some question is wrong.
yes, sir, but the marks were not modified, sir. It is showing the same marks.
Oh. At the end, I think they will modify. Okay, I will tell them that
Okay, okay, sir.
modified marks are is not being shown.
Okay, okay, sir. Actually, I think they are not considering the extension of date for this registration, sir. Till now, I didn't get any email from NPTEL.
Mm.
Okay, sir, I'll try next semester. What is this? Just this will be a practice for me.
Okay, I'll remind
I'll
them
be
this again.
solving all the assignments.
If they will
Okay, sir.
not give na, then I'll make it clear to you. If they are not in. Okay.
Okay, okay, sir.
Okay.
Thank you, sir.
Okay. Thank you.